Today, we're going to dive deep into the very heart of mathematics. We're going to explore a really revolutionary idea, one that basically questions the official rulebook that's been around for about a century, and it proposes a simpler, much more intuitive alternative.
So let's just jump right in. Math, it's supposed to be this one field that's built on pure, unshakable logic, right? But what if I told you that the formal axioms, the rules that supposedly hold everything up, don't actually line up with what mathematicians are doing day in and day out?
And this is where it gets kind of weird. You've got professional mathematicians who use and manipulate sets all the time, and they do it with incredible accuracy. But here's the thing. Most of them couldn't tell you the formal axioms for sets if their life depended on it. It suggests they're running on a totally different operating system, a set of subconscious rules that are way more reliable.
So where on earth does this disconnect come from? Well, it all goes back to the official foundation of modern mathematics, a system that has a pretty strange and, honestly, counterintuitive way of looking at the world.
The traditional system is called ZFC. Now, for what we're talking about today, the only thing you really need to know is its one central defining rule. In ZFC, everything is a set. A number, it's a set. A function, that's a set too. And crucially, the elements inside any given set are also sets. And believe me, that's where all the trouble begins.
And right here, you can see the problem in black and white. If you were to walk up to a working mathematician and ask, hey, what are the elements of the number pi? They would probably think you've lost your mind. The question just doesn't make sense. But in the world of ZFC, because pi has to be a set, that's a perfectly logical question. This formal theory forces us to see numbers not as, well, numbers, but as these bizarre, nested collections of other sets.
A perfect way to think about this is how a computer stores everything: text, images, music as binary code, as ones and zeros. The system totally works, but it's just an encoding. You'd never ask to see the pixels in an MP3 file, or listen to the musical notes in a JPEG image. ZFC basically does the same thing to math. It forces everything into this one awkward encoding system where every single object has to be a set, which leads to all these questions that just make no practical sense whatsoever.
And don't get me wrong, this isn't just some small philosophical argument. This quote from the mathematician Sheldon Axler shows you just how big the ambition is here. This isn't just about finding a new set of axioms. It's a call to fundamentally change how we think about and even teach mathematics right from the very beginning. So if that traditional foundation is so awkward, what's the alternative? Well, the proposed solution is incredibly powerful, and it flips the entire perspective on its head. It starts not with what's in a set, but with the relationships between them, functions. The big idea here, which was proposed by F. William Lawver, is to just flip the script entirely. Instead of defining everything through sets and their elements, what if we started with the concepts of sets and the functions that connect them? Okay, this is the big aha moment, and it's so simple and so powerful. Just imagine a set with only one thing in it. We'll just call it 1. Now, think about a function, like an arrow, that goes from our little 1 set over to the huge set of all real numbers. Well, that arrow has to land somewhere, right? By its very nature, it picks out a single number in that destination set. And that's it. The element is just the function that points to it.
And the real power here is in how beautifully it simplifies everything else. For instance, think about the familiar idea of evaluating a function, like f of x. That's no longer some special, separate operation. It's just what naturally happens when you combine two functions, the main function f and that little selector function x. Everything gets unified under one single, elegant language.
So with this totally new way of looking at things, what does the new blueprint for math actually look like? Well, it's a set of rules that are based on principles that, frankly, feel a lot closer to home for anyone who actually does math.
So, what's in this new rulebook? Well, as you can see, it's built from concepts that mathematicians are using every single day. It starts with the basics, like functions composing in an orderly way. It establishes there's an empty set and a set with one thing in it. It gives you the building blocks to create new things, like Cartesian products. And the key here is that these aren't some weird, abstract rules. This is the bread and butter of daily mathematical work.
So the most important point is this. This new system isn't really new in practice. It's really just an honest description of the intuitive, reliable rules that mathematicians have been using all along. It just writes down the subconscious toolkit they already trust. Which brings us to our final and maybe most important question.
Beyond just being, well, neater, why does any of this matter? It matters because this new approach isn't just more intuitive, it's also a much more reliable and robust foundation for all of mathematics.
Let's just do a little thought experiment. Imagine you wake up tomorrow, you check the news, and the headlines are screaming, ZFC is inconsistent. A fatal flaw has been found. The official foundation of math has crumbled into dust. What happens to the last 100 years of mathematical progress?
The surprising answer is not a whole lot, actually. Most mathematicians would find it fascinating, sure, but their own work wouldn't be invalidated. They wouldn't suddenly doubt if their theorems were true. Their entire life's work would still be standing.
And why is that? It's because they were never really building on ZFC in the first place. They were building on these intuitive, function-based principles we've just been looking at. A crisis in ZFC would be a huge deal for logicians, but for most mathematicians, it would just prove what they subconsciously knew all along. The real foundation of their work is stronger, it's simpler, and it's much closer to what they actually do than the official story lets on. And that really leaves us with a fascinating thought. What if the true language of math isn't about sets and elements, but about functions and arrows?